Hi, in this lecture we are going to discover another way how you can get shell access to the target server. This type of attacks are boringly called operating system command injections. This tells us that somehow we are going to be able to execute operating system commands on the server. So what happens in many time with web applications is that the developer wants to interact with the operating system somehow to whatever create files or get the current time or something like that. In most of the times, the used programming language like PHP has a built-in function to do that. So to get the time or something like that, or create a file. But in some cases, there is no function in the programming language. And then the easiest way to do this is to call shell commands on the system and do the same thing in shell. So to create a file that you can do touch in a shell command or something like that. Most of the languages have function to call shell commands in the operating system. So for instance, in PHP, there is the exec and the shell exec function. So exec and shell exec. The difference is only how the output is interpreted or returned to the program. So these are PHP functions, so you can call them in the PHP code, and you pass along a shell command what you want to execute. So for instance, if you want to list the files in the web root, then you can do the following: exec and then ls for listing files /var /bv/html. So this command is PHP, and this is the shell command to be executed. Now, a command injection happens when you can somehow manipulate the command which is executed in shell with your user input. So, for instance, the following code would be vulnerable: exec, and then starts off as the previous one, ls, but then we allow the folder to be specified. So in this case, we're taking the folder from a folder parameter in a GET request. So the URL would be like something slash whatever index dot php, and then folder is, and then the folder. However, you don't have to stop here. In shell, you can concatenate comments after each other with the semicolon or with the end symbol. So you can say like ls current folder and then echo hello. So it lists the current folder and then prints hello, because these are actually two commands. This is the first one and a semicolon, and this is the second one. You can do the same with end. The difference is that this command only gets executed if this one is successful. So in this case, we could do /index.php and then folder equals to whatever, and then new command touch /tmp/test file. So basically, when you would call this URL with this value in the folder parameter as that passed along to this exec, that will actually execute two commands. One is the ls/ and the other is the touch test file. And with that, we can basically write on the disk of the target machine. So with that, we get the command injection because we are injecting an unexpected command or even more commands in this one call. But let's see if we can find one in the person of interest. So when you did the manual discovery on this application, then you could have noticed that if you go to your user profile, under user, your profile, then there is a attribute called website. So you can add your website to your user profile. The only problem was that it didn't work all the time. So you marked it to be analyzed later. Now we are analyzing it. So first start with the normal URL, example.com. And scroll down and update profile. Profile updated. That seems fine. So now let's try with a bogus URL. It could be whatever dot something, and then update profile. And you get an error message saying that website doesn't exist, wget returned 4. So if you're familiar with wget, it's a command line tool to download something from the internet. So my suspicion is that they are using exec to call wget to check whether that website what you typed in really exists. So they just want to make sure that it's not a fake website, and they are checking it. But that tells us that we might be able to inject into this wget, because they are probably just adding the URL to the wget. And if they are not validating the URL before calling the shell command, then you might get command injection. So let's first just try to create a new file. I would say semicolon and touch, and we'll do that under the root of this app. So var www html ii, and we call the file test.txt, and then go and update profile. So profile is updated. That already sounds good. Now open another window and say the URL of the app, and then test.txt. Now the good sign is that we didn't get a file not found error. That tells us that this file exists. Of course, the file is empty, so we also doesn't get any content. But what this means is that the command injection here, this command was really executed because this test.txt was created in the web root. That's awesome. That means that we can use this to execute any kind of commands in the operating system shell. Let's try another thing. I would say cp for copy, and then etc bus with the, and then again to the web application folder. I use the web applications folder because that's what we can access from the outside. So this will copy the passvd file to the web app folder, update profile. It was successful. So let's go to the other tab and try to open passvd, and we get the file. So this means that now we are capable of extracting any files from the server. We could just copy them to the web app folder, and from there you can download it. We have more or less read access to the whole disk of the target machine. So in this case, I want to show you the source code, so the vulnerability itself. So if you go to your Kali, then log onto the target machine. and then I will become root. So here we are in the app root, and then we can find where the vulnerability is by triggering the error again and then searching for the error text. So we can search for this. So grep -r for recursive search, and here it was found, and you could see that it's under VP admin includes user PHP. So let's open that file. So the color scheme is pretty bad, so I will just quickly change that to color. Yeah, hopefully you will see that better now. And if you scroll down a little bit, we are just looking for the same error message, and it's here. So basically it says this is the checking URL, and here this is the vulnerability. So as you can see, it calls the exec and then wget and some parameters, and then it directly takes the URL from the post request and concatenates it to the command, and then the command is executed. And if the execution was unsuccessful, then it gives us the error message. So that's how the vulnerability looks like, because we are directly using the post parameter. That's always a bad idea, not to sanitize the parameter. This was probably just a mistake, because here, as you can see, it takes the URL and it does an escaping, and that's how it stores it in the user object. So the programmer could have been used the user object user URL here instead of directly from the post. So that's how the problem looks like. As an exercise, you could try to download a web shell from your own Kali, similar to what we did in the previous lecture. But what you want to do is serve the backdoor on your own web server on Kali. And then here, the injected command should be also a wget, where you download it from your own Kali and save the file in the root folder. Just check the wget how you can configure it to do that. And then you would have root shell on the application. So you could do the same thing what we did in the previous lectures, just look around and execute commands a bit more easier. When you're ready with that, you can join me in the next lecture. So take care, bye.